Hi. In this last lecture on prisoner's dilemma problems and common pool resource problems, I want to talk about why the particulars matter so much. Why when we think about real institutions and real incentive systems that can solve these problems, we have to care a lot about the real features of the world. So remember when we talk about collective action problems, these were things like it's in my incentives to burn lots of carbon fuels, but collectively we'd be better off if we burn fewer. And then we talked about common pool resource problems like managing cod or managing forest, where we want to not over-harvest or overfish. And we also talked about just standard prisoner's dilemmas, where I'm better off defecting, but collectively we'd like to cooperate. Now when we look at these things, we can write down mathematical equations. We can say, here's the canonical collective action problem, and we can think about describing some sort of mechanism or some sort of institution that will solve these. But when we think about real-world cases, there's a lot that's missing from this just simple mathematics. So we're just saying xi be some action in 0, 1, and it leaves out a lot of features of the real world. So what I want to talk about is when we think about something like a collective action problem or a common pool resource problem, which again I've got mathematically represented down here, is do we need to know more? Do we need to know more than just the simple model? And the answer is we do. Now the model again is going to be really useful as a benchmark, as a way for us to understand the problem. And then by looking at the features of the real world, we can figure out how to overcome the problem that the model has represented to us in a clear way. Because what's going on here in the collective action problem is we want to make sure that people are going to contribute in some way. In the common pool resource problem, what we want to do is we want to make sure that people aren't going to over-harvest, aren't going to overfish. So we got to think about, now that we know the problem based on the model, how do we apply this in the real world? Now again, this is Elinor Ostrom, I mentioned in the first lecture in this section. And Elinor won the Nobel Prize in economics, even though she's a political scientist, by basically showing all the different ways that people have tried to overcome common pool resource problems and collective action problems around the world by focusing on the particulars. So let's take a moment to see why those particulars matter. Let's take the case of cattle grazing on a common. This is a standard, common pool resource problem. There's a common that has grass, and if your cattle graze too much, there won't be other grass for other cattle to graze on, and eventually you might just rip up all the sod entirely and there'd be no grass left at all, and all the cattle would die. So how do you overcome this? Well, the problem is overgrazing. So how might you do it? You could think reputation, kin selection, group selection. Those may not be the right thing. So instead, what you might think is, let's create a rotation scheme. So let's say on Monday, this person gets to have their cattle on the commons, and on Tuesday another person gets to, and so on. So you might have some sort of rotation scheme. Now you can enforce that rotation scheme by tagging the cattle. So each cattle might have brands, and so therefore you could tell whose cattle were on the common and whose weren't. Similar for sheep. So by branding and rotating, you can solve the problem. And if things start to get bad, if you notice like, wow, the grass seems a little bit low, then you can pull back a little bit and have fewer cattle grazing. If there seems to be abundant grass, then you can actually let more people graze. So again, rotation schemes, branding, that would seem to work. What about lobster fishing? This is another common pool resource problem. You've got a big set of lobster, and you might think, okay, let's do the same thing. Let's just have a rotation scheme where some people can fish on Mondays, some people can fish on Tuesdays, and so on. Or maybe people can fish in different parts of the ocean or along the coast. And you might think that would solve it. But there's a fundamental difference. There's a difference between cattle grazing on the common and harvesting lobster. And that is that in the cattle case, you know how much grass has been eaten. So you have a sense of what the value of the resource is, or how much of the resource is left. And if there's an abundance, you can put more cattle on. If there's not enough, you can pull back. In the lobster fishing case, that may not be true, because the harvest that any one person gets is a random variable. And so people may not know what's happening to the overall population. So therefore, you need other mechanisms to figure out exactly what is the population size, how much are people catching. And from those other mechanisms that figure out how much is being caught, then you can decide how much people get to fish and how many lobster they get to catch. So you need other mechanisms to monitor the total population of lobster that you don't need in the case of cattle grazing on the commons. Let's take a third example, drawing water from a stream. If you think about people drawing water from a stream, let's suppose the stream runs down this way, and let's put one person up here, right, the stream's moving this way, and other people down here. This problem is now asymmetric, because this person who's at the head of the stream, they can draw water out, and it affects everybody down here. This person at the end of the stream when they draw water out, assuming there's some water for them to draw, it doesn't affect anybody upstream. So when you think about the mechanisms you need to induce cooperation in this setting, you've got to focus a lot more attention on this person than you do on this person, because the person at the head of the stream has a larger influence on people downstream than otherwise. So again, not quite the same as just rotating cattle on the common, and also not the same as harvesting lobster. So the particulars matter in each one of these cases. Hence Ostrom says, no panacea. So what we've seen in the simple lecture is that we can write down these mathematical models and say, here's a collective action problem, here's a common pool resource problem, here's a prisoner's dilemma. And by bringing that model to bear in the real world situation, we identify the nature of the problem. Once we've identified the nature of the problem, then we can use our expertise of the particular situation, embrace the particulars, take thicker descriptions of what's going on, and then construct institutions and incentives that help us solve those problems, overcome the collective action problem, solve the common pool resource problem, get cooperation in the prisoner's dilemma. All right, thank you.